Hey guys, welcome back. We have now got ourselves introduced about Hadoop. So it is time to try some HDFS commands. You're probably thinking, why are we not talking about name node, data node, etc.? We will most definitely cover those concepts in HDFS architecture lesson later. But I wanted to look at HDFS commands first. Why? We want to use the momentum right away to get our feet wet with some hands-on action. Ready? Okay. I'm logged into our Hadoop cluster. You can get access to the same Hadoop cluster that I'm accessing. If you're registered for the Hadoop in Real World course, you will already have the access. If you're going over the Hadoop Starter Kit course, go to www.hadoopinrealworld.com/starterkit to get your access if you haven't already done so. We ended the last lesson looking at how HDFS is different from the local file system. So let's continue on the discussion. Here are some of the well-known commands to work with your local file system in Linux. You would use mkdir to create a directory, cp to copy, ls to list the contents of the directory, rm to delete, etc. So let's take a look at some HDFS commands. By the way, look at the lessons notes to find the location of this file I'm looking at. Okay? So, all HDFS commands start with Hadoop fs. Before we try a HDFS command, let's try the regular ls command on the root directory, which will bring the files from the root directory in the local file system. You see the files and folders now, right? So here is the HDFS command to list the files from the root directory. As you can see, the output of local file system listing, that is from the top right here, is different from what you see from the HDFS listing right here. That is expected. Why? Because HDFS has a global view of the files in your Hadoop cluster across all the nodes, whereas the local file system can only view or list the files available locally. So let's try the same commands on another node in the cluster and see how it looks. So here I am. I'm logged in to another node in the Hadoop cluster using an admin account, and you don't have access to this node. So in this node, I'm going to try the same two commands, the ls on the root and the Hadoop fs ls command on the root. You can see right away the output of the HDFS listing is same on both the nodes. So we have 4 folders here: benchmarks, temp, user, and var on this node right here. And if you go to the other node, you will see the same 4 folders. But if you look at the ls command on the local file system, the directory structure would be a lot different. You would have files like acoda.group, hirw starter kit, hirw workshop, which you will not see in the other node. This proves that HDFS has a unified global view across all the nodes in the cluster, whereas the local file system does not have a global unified view, and its view is limited to the local file system. So let me clear this screen. Let's try some more HDFS commands. The home directory in your local file system will be /home/the username, right? So there you go. So the username here is hirw user 150430. Whereas the home directory in HDFS is configured to use /user directory as the starting point. So in our case, the home directory for this user in HDFS will be /user/the username that I'm logged in as. When you don't specify the directory name, the listing becomes relative to your home directory. So this command right here and this command right here means the same thing. So let's try both of them. So we have 2 directories for this user. Let's try the absolute path. There you go. They point to the same exact location, right? Now let's try to create a directory named Hadoop-test1 in HDFS using the mkdir command. The directory is now created. Let's do the listing and check out the directory. There you go. I see it. So we created our first directory in HDFS. So if you do a regular listing in your local file system, you will not see that directory because it is created in HDFS. Make sense? Okay. So it is very clear that the view and the content of HDFS will be different from the local file system. Now let's see how to copy files to and from HDFS. To copy files from the local file system to HDFS, use the copy from local command, like this right here. And to copy files from HDFS to the local file system, use the copy to local command. First, let's copy the file to HDFS using the copy from local. Copy from local takes two parameters. The first parameter is the source location of the file to be copied in the local file system. And the second parameter is the destination location in HDFS where the file will be copied. So let's try this. So with this command, I'm trying to copy a file in location Hadoop Starter Kit, HDFS commands, this is the file name, to the folder in HDFS. So this file right here is in the local file system. I'm copying this file into a directory in HDFS. The file is now copied to HDFS. Let's make sure. There you go. I see the file under Hadoop-test1 directory. Now let's do the opposite. Let's bring a file from HDFS to local file system using the copy to local command. So as you can see, you would use copy to local command. You would give the location of the file that you're trying to copy from HDFS as the first parameter, and then the destination location in the local file system as a second parameter. So that's very simple, right? So let's create two more directories in HDFS. So I'm creating two directories, Hadoop test2 and Hadoop test3. The directories are now created. So now let's do a listing. So I have three directories now, test1, test2, and test3, right? I'm going to copy a file from one folder to another. These are very simple commands and easy to follow, right? In the first copy, I'm trying to copy a file from Hadoop test1 directory to test2 directory. So let's try that. The file is now copied. So let's verify real quick. So in this listing, I'm using the relative path. So as I said, by default, your path starts from the user directory if you don't specify the full absolute path. Perfect, I see the file. So now let's move a file from one folder to another. So in this command, I'm going to move the file, not copy, move the file from Hadoop test1 to test3 directory. All right, it is done. So let's do a listing on Hadoop test1. The file is gone from test1 directory because we moved it to test3. So you will see the file in the test3 directory. In our previous lesson, we talked about replication. HDFS replicate each block to more than one node. And this is to help us recover from a data loss. Let's see where we can find information about replication in HDFS. Simply do a listing on HDFS. So currently I'm listing the file under the directory test3. So this number 3 that you see here is the replication factor of this file, meaning this file is divided into blocks and each block is replicated 3 times in the cluster. So the replication factor is set to 3 by default, but you can change the replication factor as you like using the dfs.replication property. So in this command, I'm going to copy a file under test.directory and I'm trying to create a new file with the copy. So while doing so, I'm also set the replication factor to 2. So this will override the default replication factor of 3. So let's try this. So when you do a listing on the new file, you will see the replication factor is set to 2 instead of the default 3. There you go. So this file is replicated only 2 as opposed to the default 3. Next, let's talk about file permissions. Changing file permissions is done exactly as you would do in Linux using chmod. The user who you are logged in as drives the permission in HDFS by default. I'm logged in as this HIRW user. So any files or folders I create, this user will be the owner. So one of the important objectives of this lesson is to understand how HDFS and file system coexist. Take a look at this slide. You may remember from our earlier lesson, when you copy a file to HDFS, the file is divided into blocks, and the blocks are stored in individual nodes. HDFS has a global view of the file even though the file is spread throughout the cluster, whereas the local file system only has a local view of the blocks that it is managing. So many Hadoop learners fail to understand this and miss the local file system involvement here, but not you, because you're taking this course. So when you upload a file, the individual blocks are stored by the local file system in each node. But where? Why we don't see them? Before we look at where the objects are stored, let's get a little more information about the file in HDFS. fsck, the file system check command, is an excellent command and will get you more information about the files or folders in HDFS. You will need sudo privileges to run this command, so you won't be able to execute the command in the cluster. So let's say I want to get more information about this dataset right here, the ELP academic data review.json dataset. So what I'm going to do is I'm going to execute an fsck on this file right here, and I'm going to ask for information about the file, the blocks, and the location of the blocks. So let's try this command. So I'm going to log into a node with an account which has sudo permission. So let me clear this screen. So there you go. The data set is about 1 GB in size. So with a block size of 128 MB, it is divided into 8 blocks, as you can see here, 0 through 7. The replication factor of this file is 3, which you can also see right here. Here you can see that all blocks are replicated properly 3 times on 3 different nodes. Here are the IP address of each node. But if there are blocks which are not replicated 3 times, you can also find that information right here. Next important information you can find is the block name and the location. So here's the block name, and here are the 3 nodes that store this block. Next important information is the status of the file itself. So here you can find this file is healthy because it's fully replicated 3 times. So now we know information about the blocks, the information about the file itself, right? But where are these blocks physically stored? It is stored in the location defined in HDFS site.xml file. HDFS site.xml is an important file which lists the properties important to configure HDFS. This file is usually defined by a Hadoop administrator during cluster setup. In our cluster, you can find this file under etc hadoop conf directory. So here's the HDFS site.xml. Let's open this file. We'll talk more about this file when we talk about the architecture of HDFS. For now, look at this property right here, dfs data node.data.dir. This property defines the location where the blocks will be physically stored in your local file system. To look at this location, again you need admin rights, so you won't be able to navigate to this folder. But let me show you. Let me switch to the root user. So I'm logged in as root to look at the directory. So let me go into the data node directory and let's navigate even further to get to see the blocks. There you go. So these are individual blocks that are physically stored in your local file system. So when you upload a file into HDFS, HDFS takes the file, divides the file into blocks, and the blocks are physically stored right here. The important thing to understand here is the local file system can only see the blocks, whereas HDFS knows how to construct the file from these underlying blocks. So far we looked at some very important HDFS commands which are very useful to work with the Hadoop cluster. We also understand the key differences between HDFS and the local file system. As you can see, storing a file in HDFS is a lot more involved internally, meaning a file has to be divided into blocks and the blocks has to be stored in various nodes. Plus, it has to be replicated. And when a user asks for a file, HDFS should know how to construct the files from these blocks. So which means it should keep track of all these blocks. That's a lot of work. So some process or processes has to be involved to perform all this work to keep HDFS fully functional. To understand what really happens behind the scenes, we need to understand the components and architecture of HDFS. So that is what we are going to see in the next lesson. See you in the next lesson.